Alright, so in this video we are going to talk about notation systems, and basically notation is the way that we describe what x can be and what y can be. So my big question is, what can x be or what can y be? But we're only going to focus on x in this video because I don't want to do two letters. Cool?
Cool.
Alright, so if I give you a basic function like f of x equals x plus 2 over x minus 3, there's a chance that we're going to hit a problem right here at the bottom. There's something that we can't have in the bottom of a fraction. What is that?
0.
0 can't be there. No matter what, 0 can't be there. And it's possible for 0 to be there if x is a certain number. And let's find out what that number is. X minus 3, and I do not want it to equal 0.
X equals positive 3.
If I add 3 to both sides, I see that when x is 3, I get 0, and I can't have 0 because that's on the bottom of the fraction. So x in this problem, x can be anything except for 3. And I need a way of telling people that. Now I could write them that, but that takes a lot of time, and I'm much too lazy to write that down. So there's a secret and a strategy that we use, which I'll show you on the next slide. Here's what that strategy is. It's that notation. It's a way of sending people a message about what x can be and what x can't be. Here's how it works. There's brackets and there is, there's parentheses and there's brackets. The parentheses is the curve. The bracket is the squared off thing. Tell me, what does parentheses mean?
It means that the number can get as close to it as possible, but it can't be whatever the number next to it is.
So it can be as close to it, but not exactly it. So if I had bracket 3, then I'm getting really close to 3, 2.99999 or 3.0001, but I'll never be 3. What does the bracket mean?
It means that it can be that.
It means it can, it means it can be the number. So it can be the number. So if I had a bracket with a 4, then can I have 4?
Yeah.
Yep. So let's look at our example one more time. And let's delete this stuff and give us some room to work with. Alright. Looking at our example, I've got x plus 2 and x minus 3. So x cannot be 3. So I know that I'm going to have 3 in a bracket. Can x be below 3?
Yeah.
Yeah. Can it be anything below 3?
Yeah.
So the way I write that is I write negative infinity. So I can count down as much as I want. Now, am I ever going to be able to count to negative infinity?
No.
Nope. So that needs to go in parentheses. Because I can get as close to it as I want, but I'll never really be able to get there. Alright, well, is that all that x can be? No.
No.
X can be bigger than 3. And it can go from bigger to 3 to how far?
Infinity.
Infinity. You can have anything for x, but again, I'll never reach infinity, so I'm going to use my parentheses. Now, in between here, I need to show that they're connected. And so the way I do that is I draw what they say is the union sign, like marriage, yay, union. I'm going to connect them with my u, and that literally says to math nerds, x can be anything below 3 or anything above 3 without being 3, which is the answer. This is called interval notation. The other kind of notation is called set notation. Set notation is really, really easy and obvious. It's us making a list. If I said, oops, not x, but my f of x, my function is these points, negative 2, 0, and 4, 5. If that's my function, then what can x be?
Negative 2 and 4.
See, so what I did here with my set notation is I just listed everything that x could be. Really easy, really obvious. Domain equals negative 2 and 4, because x can be negative 2 or it can be 4. If I wanted to list my range, I could do that also. Range is my y value, so what would my range be?
0.
Mm-hmm.
and 5.
Ooh, see, not even a warning. You knew that one. See? Oh, he's learning. Good job. Your mom will be so proud. 0 and 5. Perfect. 0 comes from here. 5 comes from there. Now, in set notation, there's this fancy little thing that you see. It looks like I wrote it here. But it goes 2 brackets and an R. What does that mean?
It means all real numbers.
Real numbers. So if I see that number, it means all real numbers, which is basically any number you can think of, anything that's a real valid number. So it wouldn't be eyeball or horseshoe, those aren't numbers, but it would be -5 or 16. And that's how we say from infinity to infinity in set notation. Beyond that, the little nuances of notation you'll pick up as you go. The real key thing is to remember the reason we have these notation rules is so we can talk about what x can be and what y can be, so that the problems make sense and you don't get nervous or scared because you're doing it wrong and you're using a wrong number.